All right. Before the midterm, we start studying for the midterm. We solve proportions. Right? We solved a lot of proportions. And not only did we solve proportions, but we gave names to the parts of a proportion. We said, hey, anything in these two spots, we call the good start. Extremes. Thank you, Josh. Thank you. Extremes. And anything in these two spots, we call the means. Yeah. Today, what I want to do is show you a special proportion, a special type, where the means are the same. All right, where the means are the same. This is called a mean proportional. All right, a mean proportion, where the means are the same and the extremes are always going to be different. That is what we're going to set up the next 2 days when we start dealing with our special triangles. Right, a mean proportion. Extremes are different, means are the same. So here's what I want to start out with this first example. Find the mean proportional between 4 and 16. What am I asking for? Hey, find two numbers that are the same that multiply to the same number as 4 and 16 do. Now, instead of guessing and checking that, because we know what 4 and 16 multiply to, or we can find out, instead of guessing and checking, what we can do is set up a mean proportion where the means are the same. Well, you can just put x and x here for now. Means are the same, and we're trying to find it between 4 and 16. So 4 times 16, we could put those at the extremes. So what is that number that's the same number that multiplies to the same thing as 4 and 16 do? And we can cross multiply like we usually do. X squared equals, go ahead, here we go. One thing I want to try to do here is more of you guys working and me just not throwing up the answers and you guys writing it down. Find it yourself, find it yourself, find it yourself. So we get x squared equal to 64. And yes, we take the square root on both sides of that. And I know all of us, hey, I don't need the calculator for that. That's 8. It's only part of the story, though. I agree. 8 times 8 is 64. So is 4 times 16. There's something else we're missing, though. 8 does work, but there's something else out there that also works. Hi, Doyle. Negative 8. Right? When you take the square root, you're left with the plus and the minus version. So don't forget about that. All right, the plus and the minus version. So plus and minus 8. Okay, both will work. All right, this is how I introduce today because these are the type of proportions you're going to set up for me. A mean proportion. Every single proportion we set up today and tomorrow, the means will be exactly the same. All right, I got to show you where we're going to use this first. All right, let's go back to our friend the triangle we've been dealing with all year long. Can you guys draw a right triangle here for me? Right triangle ABC, where B is the right angle. The first 2/3 of this unit can only be used on a right triangle. Okay, so quiz 1, quiz 2 are all going to be on a right triangle. Anything I show you can only be used on a right triangle. In addition to this right triangle, can you draw an altitude? Ooh, vocabulary time. Can you guys draw me an altitude from vertice B to the hypotenuse AC? Draw an altitude from vertice B to AC. And hopefully you have other markings on there after you draw that altitude in, because you remember what an altitude does. So an altitude from B to AC, and what else do you have on your diagram there? If this is an altitude, what else are you putting on there? Right angle symbols, yep. And wherever it hits AC, can you put that as point D? All right, now let's have some fun here. How many triangles did we just form? How many triangles are in that diagram? I got 3 triangles, right? We'll call it, instead of going ABD, DBC, ABC, let's call this one triangle 1. We'll call this one triangle 2, and then we'll call the big one triangle 3. All right, it's just easier to communicate that way. All right, can everyone please look at triangle 1 and triangle 3 right now? Triangle 1 and triangle 3. They both have what type of angle in them? Triangle 1 and 3. They both have a right angle. And we know right angles are congruent. And I believe they also share an angle. What angle do they both share? Angle A. So wait a second. They both have right angles, which are congruent, and they both share angle A. Anybody know what we know about triangle 1 and 3? They are both, Matt? They're similar. Yeah, look at Matt coming through for us. They're both similar to each other by angle. So triangle 1 is similar to triangle 3. There you go, Matt. There we go. It's going to be a good day now. All right, everyone look at triangle 2 and triangle 3 for me. Triangle 2 and triangle 3. They both have what type of angle? Right angle. They're congruent. But now they share a different angle. Which angle do they share? C. All right. So they both have right angles, which are congruent. They share angle C, reflexive. What do I know about triangle 3 and 2? Oh, also similar. All right. We're on our way now. So triangle 2 is similar to 3. And now look what we just found out. Any other conclusions? 1's similar to 3, and so is 2. So that means 1 and 2 have to be similar. Hey, so overall here, what did we just find out? All 3 triangles are similar to each other. All right, let's go a step further from when we did similar triangles. If the triangles are similar, what do you know about their corresponding sides? If the triangles are similar, what do we know about our corresponding sides? They are proportional. And you remember we had to match up the sides, right, to write our proportion? All right, I have a challenge for you, honors kids. Can anybody tell me in triangle 2, DC matches up with what in triangle 3? Can we find what DC would match up with in triangle 3? Here we go. Side DC in triangle 2 would match up with what in triangle 3? We got 3 types of people right now in this class. First type, I know what side matches up with DC, and I'm 100% confident. Second type, I think I know, but I'm not that confident. And then there's the third type, I'm out. There's no way I'm going to figure out what matches up with DC. No way. Okay? No way. And that's okay. That's great. That if you're in that third group, thank you. If you're in that third group, that's great. If you're in the first group, great. And if you're in the second group, great. What I'm going to show you today, 2 devices that will help you match up all those sides to where they correspond to. All right, 2 devices. Let me introduce the first device to match up these sides correctly. The first device is called Hills. HLLS. Where's the I, Mr. Carlin? All right, relax. There's no I in there. There's nothing that begins with an I, so that's why there's nothing there. It's HLLS. How does this help me match up the sides? Here we go. HLLS. It forms a proportion for you. Okay, it forms the proportion that matches up the sides for you. What does each letter mean, and where's it located on my diagram? The H in Hills, and it's all here too. All right, it's all here too. The H in Hills is the hypotenuse of the original right triangle you drew. So I'm going to ask my first question of the second semester here. What segment am I referring to if I'm looking for the hypotenuse in the original right triangle up here? What segment are we referring to? Here we go. Start us off on the right note here. 1-5. Gabby, which segment am I referring to? Good start. Good start. So this is the hypotenuse I would plug in Hills right there, whatever AC happens to be. All right, now let's keep going. How about the L in Hills? The L refers to leg, and it can be either leg of the big right triangle. Okay, you'll pick the one we're using. All right, whatever particular problem we're doing. So I need now somebody, can you please identify the 2 legs in this diagram? Name the 2 legs. It's the leg of the original right triangle we drew. So that would be, what are my options? Amy, go ahead.
A, B, and B, C.
Great job. Leg Either one. Okay, you're definitely going to use one out of the two because it's going to be labeled. All right, here's where I need you to lock in. This next L does mean leg. Now the question I have is, same leg or different? And the answer is it's the same leg. And you're never going to forget that because these are the means. And every time you set up hills, it's a mean proportional, which means the means are the same. All good. The legs you plug in here are the same legs. So if you use BC here, you use BC here. The means are always the same. We good. Finally, S. What the heck does S mean? That stands for segment. Okay, segment. Go back up to my diagram. When you drew that altitude in, remember I asked you to draw the altitude in? You didn't know it at the time, but you created 2 segments on the hypotenuse. That's what I mean by segment. Here's a segment AD, and here's a second segment DC. I'm sure your question is what? Which one do I use, right? In hills? Which one? Here's your answer. The one next to the leg that you used. All right, so you always use the segment next to whatever leg you put in the proportion. So scenario, let's say I used leg BC in here. All right, I put leg BC. Which segment would I use then of the 2 that I have labeled up there? If I used leg BC, which segment would be going into the proportion now? For Doyle. If I used leg BC, which segment out of the 2 would I use?
Like the triangle?
No. Name the actual segment length. Name it. So I have segment AD and I have segment DC, but I want to use leg BC in my proportion. So which segment would I use
DC.
that? DC, the one next to it. Everyone all right there? Which segment to pick? All good? All right, so that's hills. That'll help you match up the sides. Problem's going to be, though, sometimes you don't have enough information to fill it all in. So here's your second device that I have called SAS. SAS, S-A-A-S. This matches up the sides for you as well. All right, you guys have already had a little taste of this, so what do you think the S means? Segment, good job, yeah, segment. All right, new one here, A, altitude. Altitude, and remember you drew that in here, BD, there's your altitude. All right, come on, you got this with me, come on. Altitude, same altitude or different? Okay, same, it's gotta be, there's only one in the diagram. And the second thing is, means are always the same. When you set up hills and SAS, the means always have to be the same. Which brings me to my last question. Finish this! Come on, finish this! That S here for segment, different or the same as this one? Darn right, different. Because the extremes are always different, means are the same when you set these up. All right, making sense a little bit before we start using them. Hills, hypotenuse, leg, segment, and then we have SAS. Ready to use it. All right, let's see what you got. All right. Find the missing side. We know all 3 triangles are similar, so the sides have to match up. So instead of trying to confuse ourselves, all right, what's the 3 match up with? What's the Y match up with? We can use hills or SAS to do it quicker. Couple things before we get going, though. All right, you're not ready to sniff this yet. First thing, you cannot just throw out hills and SAS anytime you want, or anytime you get desperate. Put it that way, too. There's only one way you can use hills and SAS, and that is the diagram. What type of triangle is ABC? It's a right triangle. You have to have a right triangle to start out with. In addition to the right triangle, you need BD drawn in, which is what? An altitude. So the only way you use hills and SAS is if your diagram is a right triangle with an altitude drawn to the hypotenuse. All right, that's the type of diagram I need to use Hills and SAS. All right, last thing before we set up a proportion. Which one do you use? Right, I've looked at the diagram. I know it's a Hills or SAS problem. So is it a Hills or is it a SAS, right? And you're not going to guess. Here's what you look at, the altitude. Is the altitude involved? Meaning, the altitude is BD in problem number 1. Is it labeled with anything? So we're not using it. So the altitude is not involved in this problem. So that eliminates SAS. So this has to be a Hills problem. All right. If the altitude's not labeled, you can't use SAS. I need the altitude to use SAS. So this is going to be a Hills problem. All right. So to help us match up those sides, we're going to use Hills. All right. Time to call on you guys. The H represents hypotenuse of the big right triangle, the original one. The one without the altitude drawn in, right? All right. Pretend it's not there. Hypotenuse of my original triangle. How long is it? Start us off here. Ian, how long is that hypotenuse we're looking for? 12. 3 plus 9, everyone. Yep, 12. Leg. Remember, we said there's 2 legs, but there's only one involved here. All right, and what leg do I want for this one? Ooh, Gianna? All right. Remember, leg of the original right triangle. So the original right triangle is ABC. ABY. Everyone see that? When we say leg, we're looking for the original one. So Y, good job. And remember, you're setting up mean proportions here. Oh, all the time, that's what you're setting up. So what should that other L be as well? Amy?
Y.
Also Y. All right, take your time now. What segment am I referring to? There's 2 up there, 9 and 3. We always want a certain one, though. All right, we always want a certain segment in Hills. Out of 9 and 3, which one do we require here? 2, Zoe? What's that? Yep, 3. And again, why did Zoe pick 3 and not 9? We're using leg Y, so we pick the segment next to it. Good. And now we're ready to roll. All right? Those are the sides that matched up. 12 matches up with Y, and Y matches up with 3. Y squared equals 36. I can take the square root on both sides. Plus or minus? Plus or minus 6? That's what I did the first problem, right? Plus or minus. I said, don't forget the negative. What's the problem? Why don't I want the negative here? Got a diagram, right? If you have a diagram, no negative side length. So I'm not looking for plus or minus, just 6. Because if you put negative 6 in, can't have a negative side. All right, 1 doesn't make you great. Let's go to the second one. Is the altitude involved? Yeah, it's labeled. When I say involved, I mean it's labeled with a length or a variable, and this one is. So this is going to be a little SAS here. All right, let's slow it down. S for segment. So give me one of the segments that are up there for me so I can start this off. 15. Gabby, go ahead. 4, yep. Gabby could have also gave me 12, and it would have been correct. Over altitude. What do we have for our altitude here? Ian? X. Altitude again for the other side. Altitude. Where am I going here? Thomas? X, right? Yeah, there's only one altitude to use, and it's got to be the means are the same. All right, and how about the other S in SAS here? What am I going to plug in for that one, Amy? 12. Remember, segments are different in SAS, and they're the extremes too, so they should be different. All right, cross them up. X squared equals 48. If the directions don't say, please leave everything in simplest radical form. I don't need a long, non-terminating decimal. So when you get it, let me know. Square root of 48. 6. Thomas, when you have it, let me know. Good job. 4 radical 3. just the positive version. All right. It's time to see what you guys can do. So you're going to take care of this 6-pack of problems for me. You can talk in your group. Feel free. You got new groups, introduce yourself, talk to each other a little bit, or you can do them on your own. I'll give you about 4 to 5 minutes. We'll come back as a group and I'll call on 6 different people. All right, show me what you did. So take your time, talk to each other in your groups if you want. 4 or 5 minutes, we'll come back. Determine what type of problem it is. Is the altitude involved? right, let's talk this over here. Again, I'll try to speak to 6 different people. I need the proportion you set up and then your final answer. All right. Let me hear the proportion first. All right, so here we go. A. Ooh. Ian, start us off. What do you got for your proportion?
X over 6 equals 6 over 4.
Good. That was a SAS problem. Good job. And then we got X equal to 9. Yes. All right, good start. If there's any questions, let me know.
Oh, yeah.
Use number 9 and the answer's 9.
Z, why are you here? All right, here you go. I'll stick to my word. Here you go. What do you got?
Shattered.
Good catch. Good catch.
Dropped.
I heard. Yeah, I heard. I right about that.
And wheels.
Guys didn't forget, huh? Flip.
White.
We'll wipe. Anything else? Star. There's one more I could think of, but. We're good? Or okay, you ready then? Shatters. Cubes. Clock. Flip. Fade. Slide to the right. Drop. Slide left. Pinwheel. Sorry. Thanks, man. Pinwheel. Curtains. Book. Genie. Wipe. Star. The only one I thought about was swing when it comes from the corner. Swing. All right, so you got what? I'll give you the Promethean person, and we're going slide left here. All right, slide left. All right, I don't have any more, so I'll back up one. And watch, you'll probably get at this one too, because Z just pulled this out. Well, remember, it's the same number as the answer. All right, slide left and Promethean person. We ready? No homework. First day of the semester here. Thank you. The little wipe there, little wipe. So anybody that had wipe, you would have had it. All right, the 2 that had wipe needed one more. All right, is this going to happen? It might happen again, actually. I'm just looking at some of the answers coming up. It might happen again. Let's hope not. All right, so can we go back here? Part B. $12. Olivia, what do you got for your proportion?
10 over x equals x over 4.
Yep.
X equals 20.
X equals 20. Good. Just check that one, everybody. Check that one. I know it said 50, but that's the hypotenuse, and I needed both segments because this was a SAS problem. Too bad I didn't call on you coming up here. C. Oh, boy. Here we go. C. Can't go again. Olivia needs somebody else. Wow, Will's not even. God, son, Will's not even here. All right, we're good there. 8. Josh, what do you got for your proportion?
25 over x equals x over 4.
Yep, and thankfully I didn't call on. Here you go. What was your answer?
X equals
10. Good. All right. I don't think I'm going to get the next answer out of here. Sorry, but all right, next one. That would be amazing if that did come up, though. Thomas, here you go. Proportion.
12 over x
12 over x equals
equals x over 9.
x over 9. Good. And what do you have for your answer? Radical, right?
6 radical.
6 radical 3. Good. All right, next up, E. All right, this is your last opportunity, it looks like, based on my answer here. And Olivia already went, so. Ooh. Woo! 13. Christina, you ready for this bad boy? What do you got for me?
16 over x equals x over 9.
Good.
And then x equals 12.
You got it. Maybe if our class was a little bigger for this last one, the number would come up, but guess not. 4.
I didn't get what I'm doing.
All right, Doyle. When you have the proportion, let me know. Looks like it's a SAS problem.
Wait, what happens if we like tie when guessing which one the next one's gonna be?
Like if there's a couple like that one, if there's a couple with 2s.
Yeah.
You know, usually I get real egotistical, and I'm like, you're never going to get it anyway, so you can have both of them. That's usually how I go. And then it burns me because it does come up usually. But yeah, that's usually what happens. I get a little too egotistical and like, you're not going to get it anyway. You can have both of them.
Uh, 25 over x equals x over 144.
Yep. And what do you got for X, Doyle?
X equals 60.
Good job. All right, real good job. Just to warn you, we didn't go over any of these type, but you may have to factor. Remember, after you cross multiply, that it's going to be on your homework. All right, one of those problems tonight, you're going to cross multiply after setting up Hills and SAS, and you're going to have to factor. So heads up there. All right, heads up. All right, go ahead. Still got 10 minutes. Perfect time.